When astronauts first set foot on the lunar surface during the Apollo missions, they left behind more than just physical impressions on the dust and rocks of the moon. Those footprints, some of which are still visible to this day, represent a monumental achievement in human history. As symbols of exploration and discovery, they mark the farthest reach of mankind's ventures beyond Earth. However, these footprints are not just a testament to human perseverance but also to the unique conditions of the moon that allow them to persist for an almost unimaginable amount of time. Unlike the footprints we leave on Earth, those on the moon are not subject to the same forces of erosion, weathering, and natural decay. One of the primary reasons lunar footprints can last for so long is the lack of atmospheric conditions. The moon has no atmosphere, which means there is no wind, rain, or weather to wear away the marks left by the astronauts. On Earth, footprints can be erased by rain, the movement of soil, or the scuffing of daily activity. But on the moon, the lack of these natural processes means that once something is left behind, it remains largely undisturbed. The dust and regolith, the layer of loose, fragmented material covering the solid bedrock of the moon's surface, are composed of fine particles that are easily shaped when disturbed, but they do not easily erode. The moon's surface is also subjected to only minimal external forces, such as the impact of meteoroids and cosmic radiation, which affect the surface at a much slower pace compared to the more dynamic conditions on Earth. Moreover, the moon's low gravity plays a significant role in preserving the footprints. With only 1/6 of Earth's gravity, the force exerted on the lunar surface is much less than what we experience on our planet. This reduced gravity means that the astronauts' steps created deeper impressions in the loose lunar soil, and these imprints have remained intact over time. The footprints are also more stable due to the lack of moisture in the moon's environment, which would otherwise cause the particles to settle or shift in a different way. Without the usual weather patterns to disturb the surface, the tracks made by Neil Armstrong, Buzz Aldrin, and others during their historic landings are still there today, a permanent mark of their passage. The question then arises, why have these footprints survived the passage of time? The lunar surface is constantly bombarded by meteoroids, micrometeorites, and solar radiation, which could theoretically cause the destruction or erosion of any traces left on the surface. However, the size of these impacts is often too small to cause significant changes to the footprints. While meteoroid impacts create tiny craters and disturb the lunar surface, they don't have the power to wipe out the larger, more substantial impressions left by the astronauts' boots. The moon's lack of tectonic activity is another key factor. Unlike Earth, where the movement of tectonic plates can cause erosion and shifts in the surface, the moon remains geologically inactive. Therefore, there is no movement to bury the footprints under new layers of lunar soil or rock. The passage of time itself is also a critical factor. The moon's lack of atmosphere means that there is no air pressure to alter or disturb the shape of the footprints. Additionally, there is no water cycle to wash away the dust or debris that makes up the lunar surface. Over millions of years, the moon has remained relatively unchanged, and the small footprint imprints continue to be preserved as historical markers, untouched by the usual forces that would typically wear them away on Earth. Despite the moon's seemingly immutable surface, the footprints may not last forever. Over time, small particles from the solar wind, primarily charged particles like protons and electrons, bombard the lunar surface, slowly weathering it. Additionally, the moon is subjected to extreme temperature variations, which can cause minor fluctuations in the structure of the regolith. While these processes are incredibly slow, they could eventually contribute to the fading of the footprints. However, it is estimated that even with these factors, the prints left by the Apollo astronauts could remain visible for thousands, if not millions, of years. This enduring legacy of the moon's footprints has broader scientific implications as well. They serve as invaluable markers for future exploration. In fact, the footprints could help guide future lunar missions. As we look ahead to returning to the moon and possibly establishing a human presence there, the preserved footprints provide an excellent reference for scientists and astronauts. They offer a clear picture of where previous missions took place and can help future missions better understand the conditions of the moon's surface. Moreover, these footprints can provide insight into the history of space exploration. As a result, the preservation of the first human footsteps on another celestial body underscores the importance of space heritage. These marks are not just physical remnants of a single mission but part of humanity's larger journey into the cosmos. As we look forward to missions to Mars and beyond, the footprints on the Moon represent a milestone in the progression of human space exploration, a lasting reminder that we have ventured beyond our home planet and left an indelible mark in the universe. The Moon's surface, with its preserved footprints, has become a symbol of human curiosity, achievement, and the quest to explore the unknown. For those who dream of space exploration, the lasting impressions on the lunar surface serve as a powerful motivator. The fact that these footprints endure, visible from orbit and preserved for generations, reminds us of the potential for discovery and the lasting impact of our actions in the vastness of space. As we continue to push the boundaries of space exploration, the footprints on the Moon remain not only as a record of the past but also as a beacon guiding us toward future horizons. The footprints left on the Moon continue to serve as silent witnesses to the triumph of human ingenuity, but they also bring attention to the concept of preservation in space. As we examine the lasting nature of these marks, it becomes evident that the Moon offers a unique environment for maintaining human-made relics. Unlike Earth, where constant erosion, weathering, and biological activity transform the landscape, the Moon's static, harsh environment allows us to study the passage of time through physical traces that remain largely unchanged. The footprints, along with the various instruments and structures left behind by the Apollo astronauts, represent a form of space archaeology, offering a glimpse into one of humanity's most remarkable achievements. But as we look towards the future, it raises an important question: how will we preserve these marks for future generations, and should we even try to preserve them at all? The idea of preserving these traces on the Moon isn't just about commemorating past achievements. It also has significant implications for our understanding of space history and the challenges of long-term preservation in extraterrestrial environments. The Moon, despite its lack of atmosphere, is not entirely immune to forces that can alter its surface. While meteoroids may not erase the footprints immediately, they could over the course of millennia create new impacts, each one slightly altering the surface. Solar radiation also plays a role in the weathering of the lunar surface, slowly breaking down the materials. This gradual process raises the question of whether future lunar explorers should take steps to protect these historical artifacts, or if the forces of nature should simply be allowed to take their course. Interestingly, the Moon's lack of human activity since the Apollo missions is a key factor in the preservation of these marks. The absence of wind and water means that lunar objects, such as the footprints, stay where they were left. On Earth, any historical site would inevitably be altered by human presence, but on the Moon, the lack of interaction means these imprints remain exactly as they were in 1969. This preserved state, however, is paradoxically fragile. The same conditions that have kept the footprints intact for over 5 decades also make them vulnerable. If future missions were to land near the Apollo sites, they could risk disturbing these ancient relics. While some scientists advocate for the preservation of the Moon as a natural and cultural heritage site, others argue that exploration should continue unhindered. There is also a growing conversation about space tourism and the potential impact it could have on the Moon's historical landmarks. As private companies push forward with plans to send tourists to space, including potential trips to the Moon, the preservation of these significant sites may become a concern. Space tourism could lead to increased traffic on the Moon's surface, raising the likelihood of inadvertent damage to footprints, scientific instruments, or the American flag planted by the Apollo 11 astronauts. The idea of creating a protected zone around the Apollo landing sites is being considered, where future missions could be restricted in their access to these areas. This would not only preserve the historical value of the Moon's surface but also ensure that future generations of humanity could witness the same marks of human achievement that we admire today. Another aspect of the lasting footprints on the Moon is their scientific value. They are not just symbolic remnants, they are data points that can help scientists study the environmental conditions of the Moon over time. For instance, the dust that clung to the astronauts' boots as they walked across the lunar surface could provide clues about the Moon's geology, its temperature cycles, and the influence of solar radiation. The footprints themselves, in the absence of wind erosion, allows scientists to study the regolith in its untouched state, offering a snapshot of what the moon's surface looked like at that precise moment in history. In this way, the footprints on the moon are more than just the legacy of human exploration, they are part of a larger scientific record that may one day be invaluable in understanding the moon's history and its potential for future colonization, in addition to the footprints. The Apollo missions also left behind a wealth of artifacts that offer insight into the technological advancements of the 1960s. Tools, rover tracks, scientific instruments, and even the lunar module descent stages can still be found on the moon's surface. These items are historical time capsules, frozen in time, providing a glimpse into the technology and methodology that made the moon landing possible. The preservation of these artifacts, much like the footprints, plays an important role in keeping alive the legacy of space exploration. However, much like the footprints themselves, the preservation of these items faces an uncertain future. Future missions, technological advancements, and even natural processes could impact their state, and the question arises once again, how do we protect these artifacts without hindering future exploration? One solution being proposed is to create an international framework for the protection of lunar sites. Similar to how UNESCO protects World Heritage sites on Earth, such a framework could establish guidelines for how future missions to the moon should approach historical landing sites. Such agreements could include protocols for maintaining the integrity of the footprints, flags, and equipment left behind by the Apollo missions. By treating the moon as a cultural and scientific heritage site, humanity could ensure that the historical significance of these lunar landmarks is preserved for future generations. This approach would require cooperation between governments, private space companies, and international organizations to balance the desire for continued lunar exploration with the importance of safeguarding these priceless artifacts. Beyond the moon itself, the preservation of the footprints also has broader implications for humanity's legacy in space. As we continue to look towards Mars, asteroids, and beyond, the question of how we handle space history will inevitably come into play. How will we treat the marks left by early space explorers? Will we leave future generations with a record of our accomplishments, or will we unknowingly erase the traces of our journey? The footprints on the moon serve as a reminder that the human desire to explore the cosmos is not a fleeting moment in time but part of a larger, ongoing story that stretches across centuries and millennia. As we venture further into the unknown, we must decide what we want future generations to inherit from our explorations, and whether we have a responsibility to preserve the marks we leave behind. The conversation surrounding the preservation of lunar footprints is just beginning, and as space exploration continues to evolve, so too will our approach to the legacy we leave behind. These footprints on the moon remain not just as evidence of our past, but as beacons for the future, showing that humanity has the potential to reach beyond Earth and leave its mark on the stars. The enduring footprints on the moon represent not only humanity's triumph over gravity and the unknown but also symbolize a pivotal moment in human history. As we venture further into the cosmos, these footprints continue to provoke deeper questions about space preservation, cultural heritage, and our responsibilities to future generations. The moon, as the first celestial body visited by humans, provides an ideal case study in the long-term effects of human exploration and the need for thoughtful conservation of extraterrestrial environments. The prospect of humans returning to the moon, as well as venturing to Mars and beyond, brings with it new challenges related to the preservation of space artifacts. The footprints, scientific equipment, and other remnants left by the Apollo missions are not just markers of our past but also foundational stepping stones for the future of space exploration. In terms of ethical responsibility, preserving these sites becomes a matter of reflecting on the broader implications of human activity in space. Much like how humanity has developed laws to protect natural heritage sites on Earth, there is increasing interest in developing frameworks for the ethical management of extraterrestrial exploration. The moon's heritage sites are not just relics of national achievement but part of our shared human legacy. As commercial companies, national space agencies, and private entities look towards lunar missions in the coming decades, the question arises, how do we balance the desire for exploration with the obligation to preserve these significant marks? Space agencies like NASA have already considered the ethical implications of human presence in space. and discussions are underway on how to safeguard cultural landmarks. One such initiative is the concept of space tourism, which may involve private citizens traveling to the moon. How will this form of tourism affect the historical sites that remain on the moon's surface, and how can we ensure that future visitors understand the profound significance of what they are witnessing? The desire to preserve the Apollo landing sites is further complicated by the fact that the moon, as an uninhabited, barren world, has no governing body or international treaties in place to protect it. While the 1967 Outer Space Treaty declares that no nation can claim sovereignty over the moon, the treaty offers little in the way of provisions for the protection of lunar heritage sites. Currently, there is no global consensus on how to preserve the footprints and artifacts from the Apollo missions, and the question of ownership and stewardship is still being debated. Should a historical site on the moon be considered a universal treasure, protected by international laws, or should the responsibility lie solely with the nation that placed its footprint there? How do we ensure that private companies, who may one day colonize parts of the moon, understand the importance of respecting these spaces and treating them as protected heritage sites? One of the proposed solutions to this dilemma is the establishment of an international lunar heritage framework, which could serve as a set of guidelines for the management and preservation of lunar sites. This could involve designating specific areas on the moon as heritage zones that are off-limits to any future development or exploration, much in the way UNESCO protects World Heritage sites on Earth. Such a framework would involve collaboration between spacefaring nations, international organizations, and even private entities, with the goal of ensuring that future exploration does not come at the cost of erasing humanity's first steps on another world. A legal structure like this would not only help preserve the history of space exploration but would also foster international cooperation, as all parties involved would recognize the significance of these sites as part of our collective legacy. As we plan future lunar missions, especially in the context of establishing a permanent human presence on the moon, the issue of preservation becomes even more complex. Lunar bases or colonies could eventually become centers for scientific research, mining operations, or even tourist destinations. With such activities come the risks of disturbing historical sites, including the Apollo landing sites. For instance, large-scale construction on the moon's surface or the development of permanent structures could inadvertently damage the preserved footprints or even cover them with layers of lunar soil. This raises the possibility of creating a buffer zone around these important sites, where no construction, excavation, or landing activities would be allowed. Such a zone would ensure that the historic areas of the moon remain undisturbed for future study and inspiration. The advent of robotic exploration further complicates the conversation around preserving lunar sites. Robotic rovers and landers, many of which are already making their way to the moon, may also have an impact on these preserved locations. While these machines are often smaller and less invasive than human activities, their presence still requires careful consideration. The dust and debris they stir up can drift across the surface, potentially affecting the footprints and other fragile remnants left by the Apollo missions. Additionally, as we send more sophisticated robots to study the moon and its geology, we may need to consider the development of specialized equipment designed to protect and preserve the integrity of these historical sites. This challenge is not unique to the moon. As we set our sights on Mars, we will likely encounter similar ethical and practical questions about preserving the traces of early human exploration on another planet. Unlike the moon, which is primarily of historical and scientific interest, Mars offers the possibility of establishing human colonies and even terraforming certain regions. The presence of humans on Mars will inevitably alter its landscape, just as it has on Earth. Preserving the first footprints, tools, and bases left on Mars will require the same careful thought and planning as preserving the moon's historical sites. It is likely that we will need to create similar frameworks for planetary stewardship, with an emphasis on respecting the achievements of previous missions while ensuring that future exploration can occur without erasing these precious markers of human progress. The potential for future scientific discoveries in these preserved areas is yet another argument for their protection. The moon's surface, especially near the Apollo landing sites, is an untouched repository of information about the early solar system. By carefully preserving these sites, We retain the possibility of discovering new insights into the moon's geology, the history of human exploration, and even the conditions that existed on the lunar surface during the Apollo missions. Furthermore, the tools and equipment left behind by the astronauts may one day be studied to learn more about the technologies of the past and how they influenced the development of modern space exploration. In this way, the moon's footprints are not just artifacts from the past, they are living pieces of a broader scientific story that continues to unfold. The preservation of lunar sites and footprints ultimately represents a balance between celebrating human achievement and ensuring the sustainability of our explorations in space. As we prepare for future missions, the decision to safeguard these historic locations will shape how future generations of scientists, explorers, and space enthusiasts view the moon and the legacy of humanity's first steps beyond Earth. Preserving these marks is not merely a matter of maintaining a piece of history, it is about ensuring that our future in space honors the milestones of the past, guiding us forward with the same curiosity and respect for the cosmos that led to our first footprints on the moon. The preservation of lunar footprints and artifacts leads us to an important discussion on the scientific legacy of human exploration in space. The footprints left by Apollo astronauts serve as tangible links to a moment in history. But they also present an opportunity for future generations of scientists to study the moon's surface, the technologies used during the missions, and the long-term effects of human activity on extraterrestrial environments. In preserving these footprints, we are not merely holding on to symbols of past achievement, we are ensuring that they continue to inform our understanding of space exploration and its potential future applications. The untouched, static nature of the lunar environment offers a unique chance to study how both natural forces and human intervention can shape the surface of another world over time. While the physical preservation of lunar sites is crucial, there is also the issue of data preservation. During the Apollo missions, astronauts left behind a wealth of scientific equipment, including scientific instruments, cameras, and other tools designed to measure various aspects of the lunar environment. Many of these instruments were never recovered, and they remain on the moon today, serving as time capsules of human exploration. The data that was collected by these instruments, although not immediately available, could hold valuable insights into the moon's geophysical properties and the conditions faced by astronauts during their stay. As technology advances, new methods could allow us to recover or analyze this data, possibly providing answers to questions we have yet to ask. In the broader context of lunar preservation, it's important to consider how future missions will interact with these historical sites. The moon is not just a static world, it is a target for ongoing exploration. The upcoming Artemis missions and future human landings on the moon will undoubtedly encounter the footprints and artifacts left by the Apollo missions. These missions are aiming to establish a more permanent human presence on the moon, which could include constructing bases or other structures. The question arises, how do we balance the need for exploration and development with the responsibility to protect these sacred historical sites? The solution may lie in creating protected areas on the lunar surface. Much like how UNESCO protects World Heritage sites on Earth. A delicate balance must be struck between utilizing the moon's resources and maintaining the integrity of the sites where humanity's journey into space first began. In addition to the moon itself, the concept of extraterrestrial preservation may extend to other celestial bodies as well. Mars, for example, has been a target for exploration since the early days of space research, and as we move closer to sending humans to the Red Planet, the issue of preserving human footprints there will become equally important. The desire to maintain the first marks of human exploration on Mars and other bodies in the solar system may influence how we approach future colonization efforts. Should we, as a species, actively seek to leave behind permanent markers of our presence, or should we work to minimize our environmental impact as much as possible? This question, which goes beyond the moon, will need to be addressed as humanity sets its sights on exploring more distant worlds, the preservation of lunar footprints also touches on the ethical considerations surrounding the treatment of celestial bodies and the artifacts we leave behind. Space exploration has always been driven by the pursuit of knowledge and discovery, but as our capabilities expand, we must consider the broader implications of our presence on other worlds. If we view the moon and other celestial bodies as shared heritage rather than private territories, we may develop a more respectful and sustainable approach to exploration. This mindset would extend beyond the moon's footprints and artifacts to encompass the broader space environment, ensuring that we preserve the integrity of space exploration for future generations. If we approach space with the understanding that we are guests in a vast and fragile universe, we may foster a sense of responsibility that guides our future activities. An important aspect of this conversation is the concept of intergenerational stewardship. The footprints left on the moon are not just reminders of one particular moment in human history, they are markers of humanity's place in the broader timeline of space exploration. Just as we look back at the achievements of earlier explorers on Earth, future generations will look to the moon's surface and consider how their ancestors interacted with the cosmos. The preservation of lunar sites becomes a question not just for those alive today, but for those who will one day explore space in ways we can't yet imagine. How will we pass on this heritage, and what legacy will we leave for those who follow in our footsteps? Space agencies and private companies will likely have to collaborate in developing standards for how to preserve not only lunar footprints but also other elements of space exploration history. As private companies like SpaceX and Blue Origin push the boundaries of spaceflight, they will likely be involved in the preservation efforts of space artifacts and lunar heritage. A collaborative approach that involves both public and private sectors, along with international bodies, will be essential to ensure that space exploration remains a shared enterprise, one that recognizes the importance of preserving human achievements while advancing new frontiers. This collaborative effort will require careful consideration of the long-term impacts of our activities in space, including how we leave our marks on other worlds. The study of space, particularly the moon, also presents a unique opportunity to understand the history of planetary science. As scientists continue to examine lunar samples, analyze data from satellites, and study the surface using advanced technology, we will deepen our understanding of the moon's formation, its geological history, and its potential role in the future of space exploration. The footprints left on the moon may one day serve as important clues in this ongoing investigation. They are not just a symbol of our human journey but also a valuable part of a larger scientific puzzle. As we look forward to the future of space exploration, the question of preserving human footprints on the moon transcends the realm of nostalgia or sentimentality. It is about safeguarding the history of our species' efforts to explore the unknown and ensuring that our legacy will endure. The footprints on the moon are a testament to the indomitable spirit of discovery that has driven us to venture beyond our home planet. They remind us that space exploration is not a singular achievement but a collective effort that spans generations. By preserving these marks of progress, we are not only honoring the past but also setting a precedent for the future.